Hello, I'm happy to be back here with you, and I'm bringing you a new math puzzle. This one is about racing. Check this out. While the red car completes one lap, the yellow is at 2/3 of a lap and the blue car is at 3/4 of a lap. After how many laps will the red car meet again at the same time with all the other cars at the starting line? That's the question. And the red car is faster. I think the blue is a bit slower, the yellow is a bit slower, but they will complete laps, and there's one point that they will be all at the same time on the starting line. When will be this situation? And you have to find out how many laps will the red car be on this case. And a quick hint, this has to be, you're going to use your knowledge about least common denominator to solve this puzzle, okay? Think about it, and at the end of the lesson we'll be back to the solution. Today we're going to work on chapter 6, rational expressions, and section 6.5, solving equations containing rational expressions. The first objective is to solve equations containing rational expressions, and to solve the equations containing rational expressions you have to clear all the fractions, and we're going to use the least common denominator. You multiply both sides of the equation by the least common denominator of all the fractions. Then you solve as usual. Let me see if we have an example so I can show you what we're talking about. We are talking about first finding the least common denominator of all the fractions. So we have this equation, and you know that equation is kind of an expression. You're going to have numbers, fractions, variables, and operators. And if you have an equal symbol, you have an equation, right? So we have an equation here. 5/3x plus 1 equals to 7/6. This is a rational equation because we have fractions, we have rational expressions, and we need to find the least common denominator of all the fractions that involved in this equation. We have 3x is one denominator and 6 is the other denominator. So the denominators are 3x and 6. Remember, to find the least common denominator, you need to identify all the unique factors. And 6 is 2 times 3. This is better to write the denominators using the factors or the prime numbers in the case of the numbers. So we have 3x, we have 2 times 3, the least common denominator is equals, one unique factor is 2, another unique factor is 3, and the last unique factor that we have here is x. That means it's the least common denominator is equals to 6x. That's what we're gonna use. So multiply both sides. We're gonna multiply both sides of the equation by what? By the least common denominator, 6x. So multiply both sides by 6x. Don't forget to apply distributive property, especially here because you have two terms. Apply distributive property, and then you have 6x times what? Times 5/3x. Plus 6x times 1 equals 6x times 7/6. And the whole point is to simplify, to be able to cancel all the denominators. Let me see if we can do this. 6x divided by 3x is 2, and 6 we can cancel out with 6, and that means we will have only remaining 2 times 5. And let's write the results here. 2 times 5, that's 2 times 5, 10, right? Plus 6x equals x times 7, 7x. Look how nice. Now we have an equation, very simple, with no denominators, no fractions, and we can solve by using addition property, multiplication property. We know how to do this, right? Applying addition property, we're going to move this positive 6x to the other side. If we apply addition property, it will show up on the other side with the negative, right? Negative 6x. So 10, oops, use a different color. 10x equals 7x minus 6x. That means x equals 10. That is the answer. And don't forget to check. It's always good to check, but especially when we're talking about rational expressions, because if you find a solution that makes the denominator equals to 0, this is not a good solution. This is not in the domain. So you have to check, and two reasons you have to check: to make sure you have the right answer, and to make sure you don't have an answer that's not in the domain, that makes the denominator equals to 0. So check, plug in x equals 10 into the original equation, and if it's true, it produces a true statement. That's it. This is an adequate and good answer. And the step by step to solve equations containing rational expressions. Step number 1, multiply both sides of the equation by the least common denominator. Step number 2, simplify both sides. Step number 3, determine whether the equation is linear, quadratic, or higher degree to solve. And after you find the solutions, check into the original equation to make sure you have the right solutions. Another example, now we have the equation 1 over 2x minus 1 over x plus 1 equals 1 over 3x squared plus 3x. And we have to find the first step, find the least common denominator, okay? Least common denominator, let's use this, just use this side of the screen to find the least common denominator. It's going to be a process because we have a few denominators here, and one of them, at least one, I'm checking here, we have to factor out. Well, we have 2x, we have x plus 1 is another, and we cannot factor out, we cannot factor, but we have 3x squared plus 3x. First we can factor out 3x, and then we will have x plus 1, right? Right? This is 3x squared plus 3x. Okay, it's factored. Those are the denominators. To find the least common denominator, write down all the unique factors. We have 2, we have 3, we have x is a unique factor, and we have x plus 1. All the unique factors are here. Okay, so this is plus. So the least common denominator is 2 times 3 is 6. 6 times x plus 1. We don't have exponents, so don't need to be worried about exponents. Least common denominator, 6x times x plus 1. Oops, it's going to be a little bit squeezed. Right, least common denominator equals 6x plus 1. Now multiply both sides of the equation by this least common denominator, okay? Multiply by this least common denominator that you just found. Let's work this out here at the bottom. And 6x times x plus 1 over 2x minus, and least common denominator times 1 is 6x, x plus 1 over x plus 1, and check this one out. It's going to be a bit squeezed. Let's erase this, okay? Because we found the least common denominator and we have more space. So erase all this, and great. So 6x times x plus 1 over what? Over, and let's factor it out just to make sure we understand what you're doing. 3x times x plus 1. Nice. Next step, cancel or simplify everything that you can. Step number 2, simplify both sides. So let's check all the things that we can simplify, and we can divide 6x by 2x, and we have 3, and we can simplify x plus 1 with x plus 1, and this x we can cancel out with x plus 1 with x plus 1, divide 6 by 3, we have 2, and yes, we simplified lots of stuff. Now we got rid of all the denominators. Check this. Oops. All the denominators are gone. We have only the numerators, or a simple expression, 3 times x plus 1, and instead, let's apply the distributive property so we can save time, okay? Distributive property, 3 times x plus 1 is 3 times x, 3x, 3 times 1, 3, negative 6x is the only thing, and on the other side we have just 2. That's it. Nice. Cool. Move this positive 3x to the other side. It's going to become a negative. This is addition property of equality. Remember, 3x minus 6x, negative 3x, right? And 2 minus 3, negative 1. That means x equals 1 over 3. That is the answer that we are looking for. Don't forget, check your answer, substitute the value you found into the original equation. And after you do that, check if this will produce a true statement. And yes, it produced a true statement. So you can say that the solution is x equals 1 over 3. Okay? Another example. Check the next example is we'll have 1 over x minus 1 equals 2 over x plus 1. Very interesting, because first you have to find the least common denominator. And can you identify all the denominators? We have x minus 1 and we have x plus 1, right? Those are all the denominators. The unique factors will be x minus 1 times x plus 1. Sorry, this is squeezed. X minus 1 times x plus 1. This is the least common denominator. And write it. Okay, multiply both sides by the least common denominator you just found. Multiply. Don't forget, we don't need to be worried about distributive property. We have just one term, right? So this is not going to be so hard. Multiply, and is x minus 1 times x plus 1 times 1 over x minus 1 equals 2 times x minus 1, x plus 1, over x plus 1. Simplify both sides, because we can cancel out x minus 1 and x minus 1, x plus 1 to x plus 1, great. And apply distributive property here, distributive property, x plus 1 equals what? 2x minus 2. And you can think the best thing is to move this to the other side. Addition property of equality will become a negative. You can move this to the left hand side. Again, addition property of equality. So you will have 1 and negative 2 becomes positive 2 equals 2x, and positive x becomes negative x. This will make, erase this, x equals 1 plus 2, 3. Okay, this is the answer, but before you celebrate, check if it is an adequate answer, good answer, because sometimes, as I told you, it can make the denominator be equals to 0, and we don't want this kind of answer. Substitute the values that we just found into the original equation, and then we're going to have this 1 over 2 equals 2 over 4. True statement, no denominator equals to 0. That is perfect. We can now say, yes, the solution is x equals 3. Let's work on another example. Now we have this. 12 over 9 minus a squared plus 3 over 3 plus a equals 2 over 3 minus a. So let's use this side here to find the least common denominator. Okay? Find the least common denominator, and we have 9 minus a. Can we factor it out? Check. Try to remember 9 minus a. Can we factor it? We have the other denominators, 3 plus a and 3 minus a. But this 9 minus a is a special case. We have seen this on section 5.7, and it's called difference of perfect squares, because you can write as 3 squared. 9 is 3 squared, right? 3 squared minus a squared, and we can rewrite this kind of thing, this kind of expression, as 3 minus a over 3 plus a. We can factor it out, right? Remember this? It's called difference of perfect squares. So if we want the least common denominator, we need the unique factors, and we have 3 plus a, and it's here as well, 3 plus a, and we have 3 minus a is another unique factor. The least common denominator equals 3 plus a times 3 minus a. Let's apply, let's use this least common denominator that we just found. Let me write here, make it more clear. Least common denominator we just found to be 3 plus a times 3 minus a. And we can clean this up. Let's multiply both sides of the equation by this least common denominator. Multiply by the least common denominator, multiply by the least common denominator, and we will have first 12 multiplied by 3 plus a, 3 minus a, over 9 minus a. We know we can factor it out, right? 3 minus a times 3 plus a, plus Now I have 3 times, we are applying distributive property. Don't forget, distributive property. 3 plus a times 3 minus a over 3 plus a. And equals 2, 3 plus a, 3 minus a over what? Over 3 minus a. And now you're gonna be really scared because you have a huge equation. That's a lot of stuff, a lot of factors, a lot of terms. And but calm down, because you can simplify. You're gonna see that you're gonna simplify lots of things. We can cancel out 3 plus a with 3 plus a, 3 minus a with 3 minus a, and here we also can cancel out 3 plus a with 3 plus a, and on this fraction 3 minus a can cancel out with 3 minus a. Yes, it looks like we canceled all the denominators. We don't have denominators, and just don't forget to apply here distributive property. Distributive property, and we will have 12, nice, 12 and nothing else, plus 3 times 3, 9, 3 times negative a, negative 3a, equals to 2 times 3, 6, 2 times positive a, 2a. That's it. All this whole very complicated thing, lots of terms, lots of factors. It became a very simple equation. We will apply addition property by moving this to the other side, and when we move, we change is a negative, it becomes a positive, and we can move this number to the left hand side, it will become a negative. Okay? 12 plus 9 minus 6 equals 2a plus 3a. So 12 plus 9, 21, 21 minus 6, 15, 15 equals 2a plus 3a, 5a. That means a equals 15 divided by 5, 3. 3 is the answer that we're looking for, but before you celebrate that you just found an answer, check to see if this is a good answer, an adequate answer, because sometimes it makes, as I told you, the denominator equals to 0, or we made a mistake. So let's check. Substitute the value x equals 3 into the original equation and check if it produces a true statement. But have a look at that. When you substitute 3 into the original equation, you're going to have 0 as denominator. That means no, this is not allowed. 3 is not a solution, and the equation has no solution. This equation has no solution. Okay? And see how important, as you can see from the previous example, it is important to check the proposed solution into the original equation. Now we have another example, x plus 2 over x squared plus 7x plus 10 equals to 1 over 3x plus 6 minus 1 over x minus 5. Okay, let's work this out, and we need to find, as usual, the least common denominator. Least common denominator. We have a few, let's just start with the tiny ones. We have this, and we can factor it out. 3x plus 6, this is one of the denominators. 3 times x plus 2. And x plus 5, we cannot factor out, x plus 5. And we have this, look. X squared plus 7x plus 10. A good thing would be to factor it out. We can apply AC method, I think it's a good method to find the factors. And a times c is 10, b is 7, so the two numbers that multiplied is equals to 10, and you can sum, you can add, is equals to 7, is going to be 2 and 5. 2 and 5, 2 plus 5, 7, 2 times 5, 10. So we can factor out this polynomial by x, the factors, x plus 2 times x plus 5. So let's write down here x plus 2 and x plus 5. The least common denominator is going to be, and it's going to be, let me write here, least common denominator is what? The common factors, and the unique, write down the unique factors, and we have a 3 is one unique factor. We have x plus 2 here and there is another unique factor, x plus 2, and we also will have another unique factor, x plus 5 times x plus 5. Okay, this is the least common denominator. Let me clean this, because now we will multiply both sides of the equation using this least common denominator that we just found. Okay, multiply both sides using the least common denominator. Don't forget to apply distributive property. Let's multiply now both sides of the equation by the least common denominator. And the first we have this denominator, x plus 2, times the least common denominator, 3 times x plus 2 times x plus 5 over, and we can represent this using the factors, right? X plus 2 times x plus 5 equals 1 times 3 x plus 2 x plus 5 over 3 x plus 2 minus 1 times 3 x plus 2 x plus 5 over x plus 5. Yeah, this is huge. It's a huge equation, but don't need to be worried, because now we will check all the things. We will find out all the things that we can simplify, and we can cancel x plus 2 with x plus 2. We can cancel x plus 5 with x plus 5, and we also can simplify 3 with 3, x plus 2 with x plus 2, and on this last fraction we will have x plus 5 and x plus 5. Lots of things that we simplified. We got rid of all the denominators. See, we check only the numerators to see what's left is still remaining, and we have here, don't forget to apply distributive property. Don't forget, and here as well, distributive property. So we will have 3 times x plus 3 times 2, 6, equals x plus 5 minus 3 times x minus 6. Okay, all this whole huge equation now becomes a simpler one with no denominators, no fractions, and we can solve using addition property of equality, multiplication property of equality. We can move this to the other side with a negative sign, and we can move this and this to the left hand side. Change the sign, this will become a negative, this will become a positive. We will have 3x minus x plus 3x equals 5 minus 6, and this will become negative, so minus 6. 3x minus x, 2x plus 3x, 5x equals 5 minus 6, negative 1, negative 1 minus 6, negative 7. That means x equals negative 7 over 5. This is the answer, negative 7 over 5. Let's check now, see if you got if you didn't make any mistakes. If we didn't make any mistakes, plug into the original equation and find out if it's a true statement. It's going to produce a true statement. Just after you do that, you will find out it produces a true statement. And you can say yes, x equals negative 7 over 5. Right? You can do by yourself. This is your homework today, is to find and check if x equals negative 7 over 5, if it is really a solution for the equation, the original equation. All right, now we are back to our math puzzle. Now remember, this is going to be an application of least common denominator. Let me explain. Because if the red car is turning, is going around the circuit, the track, right, and is passing through the starting line several times, and also the blue car and also the yellow car, at some point, depending on the number of laps, they will be all completing laps at the same time. But of course, the red car is ahead because it's faster. The blue car is a few laps behind. The yellow car a few laps behind the red car. And but they are all completing at the same time a lap. If the blue car completes one lap, and then the red car completes one lap, the blue car will be at 2/3. And the yellow car will be at 3/4 of a lap. We need to find a number that multiplying all these fractions will make the fractions integers. Will make each one of these fractions an integer number. That means they are completing laps. They are doing an complete an integer number of laps. And this is the least common denominator. Is the smaller number that you multiply by a bunch of fractions, and you make them all integers. The least common denominator between 1, 3, and 4 will be 12. So the red car will complete. It's going to be here, completing 12 laps. And then the blue car is going to be right here, completing 12 times 2, 24 divided by 3, 8 laps. The yellow car, will complete 8 laps. And the blue car is 12 times 3, 36 over 4. The blue car will be completing 9 laps at the same time. The answer is 12. The red car will be completing 12 laps when it meets with all the other cars. And yes, 12 is the right answer. Thank you for watching this video and working together. And I hope to see you again on the next section.